Morning students, welcome to Narayana virtual classes. So this assignment is regarding electromagnetism. In this, what is our first question? What is the pattern of field lines inside a solenoid around the current carrying solenoid? When a solenoid is carrying current, we know that the magnetic field lines around the solenoid will be like this. So this is how the magnetic field lines, this is solenoid actually, and see here how the magnetic field lines around the bar magnet. Actually current carrying solenoid is equivalent as bar magnet. So that now the magnetic field lines around this also similar. Here we can clearly show how these are closed loops. Then the direction of magnetic field lines outside is north to south, inside is south to north. So finally we can conclude that the magnetic field pattern inside the solenoid is parallel to each other. Magnetic field lines are parallel to each other. They are straight and parallel to each other. Then coming to second one, what is second question? If there is an angle between the direction of field and velocity, then what is the magnetic force experienced by a charge? We are having formula. Actually in vector form we can write this as F bar is equal to Q of V bar cross B bar. Then we also can write this is QVB sin theta. So this, if you expand, you will get QVB sin theta, where theta is angle between velocity and magnetic field. He given that if there is an angle between the direction of field and velocity, what is the formula for magnetic force? F is equal to, you can write this QVB sin theta. Then coming to next question, that is third one. What is the direction of magnetic force when the velocity and charge are perpendicular to the magnetic field? We know that the property of cross product, that is the direction of this force is always perpendicular to the plane containing V bar and B bar. You all know that in case of vector product, if you take I cap cross J cap, you are going to get K cap. So similarly here the direction of this force, the direction of magnetic force when these both are perpendicular to each other is perpendicular to the plane of V bar and B bar. Then coming to fourth question, what is fourth question here? So how can you say that the motion of electrons is affected by the magnetic field? The motion of electrons is affected by the magnetic field. For this we are having a small activity, that if you are taking a bar magnet and this bar magnet or any type of magnet bringing nearer to the TV, then what happens when electrons are in motion inside that? So near the screen, as they are in motion, when a bar magnet is bringing nearer to the charge is in the presence of magnetic field, then it is affected. How we can say that that is affecting? By observing that the picture of TV getting distortion. So due to that distortion, we can say that the electrons are affected due to the magnetic field. Then coming to the fifth question, what is this? Find the magnetic force when charge Q move perpendicular to the magnetic field. This is what we discussed in second question also. F is equal to QVB sin theta. Then when both are perpendicular means theta is 90 degrees. Theta 90 degrees means this value is 1 sin 90. Then we are going to get the maximum force that is acting on the charged particle, that is F is equal to QVB. The next one in this fifth question itself, he given that what is the value of magnetic force when charge moves, this is the case, that is parallel to the magnetic field. If it is moving parallel to the magnetic field, means this is the direction of magnetic field B bar. If you take uniform magnetic field will be like this, the space between the two lines is same and the direction is also same. If a charge that is moving inside this with a velocity V bar, when both are parallel to each other, the angle between these two vectors is 0, then you can say that theta is equal to 0 degrees. When theta is equal to 0 degrees, F is equal to QVB sin theta, and this theta is 0 means sin 0 is 0, then net force acting on the charge is 0. But here one point we have to remember that, sir, when there is no net force, whether the charge will move or not, charge definitely will move. Though the force is not acting on this charge will move. because of the initial velocity that what we have given to the charge. So this is what about fifth question. Thank you students. Thank you.